Matrices are a way to organize data. In the real world, matrices can be used in computer science for computer graphics. They can be used for probability simulations or economics simulations. It can also be used to solve systems of equations, which we'll be doing later in this unit. The main purpose of me using this unit right now is to just give you a little exposure to it, but also for you to practice your adding, subtracting, multiplying, and dividing with negative numbers. In this particular part of the packet, you will arrange data in a matrix, you will add and subtract matrices, and you will perform scalar multiplication on matrices. As I said, a matrix is a type of table that's used to keep information organized in lists. Matrices have their own notation and form and their own unique arithmetic, which you'll be learning over the next few lessons. Matrices are described by the number of rows and columns in a matrix. A 3x2 matrix has 3 rows and 2 columns. A 2x3 matrix has 2 rows and 3 columns. These are not the same. In example 1, it says the table below shows the number of members in each section of 2 marching bands. Arrange the data in a matrix. Give the dimensions of the matrix. Well, we could go ahead and put North Mount High in our first row and West in our second row. And then our columns would be percussion, brass, and woodwinds. And we were basically just taking this information from the table and putting it into this matrix. This matrix has 2 rows and 3 columns, so it's a 2x3 matrix. Next, we're going to move on to matrix addition and subtraction. Matrices can only be added or subtracted when the matrices are of the same order or have the same dimensions. They are added or subtracted by simply adding or subtracting the corresponding positions. The sum or difference of 2 matrices of different orders is undefined. For example, if we had A and B, these are 2 different orders. One is a 2x2 and the other is a 3x2. So this would be an example of undefined. Now in our next example, these two are both 2x3 matrices, so we can go ahead and add corresponding parts. So for example, 0 plus a -2 is -2. 5 plus 3 is 8. 3 plus 5 is also 8. -2 plus 7 is 5. 6 plus a -9 is -3. And -8 plus 6 is -2. Subtracting. Remember, subtracting with negatives, you have to add the opposite. So for this subtraction problem, -6 minus a -5, you would go chop, chop, and it's really -6 plus 5, which is -1. 7 minus 6 is 1. 2 minus 0 is 2. And -3 minus -4, again, you would go chop, chop, so it's -3 plus 4, which is 1. The last thing we're going to do is move to scalar multiplication of a matrix. To multiply a matrix by a number, multiply each entry in the matrix by the number. The scalar is the number by which the matrix is multiplied. For example, if A is equal to this right here, finding 5A is just taking and multiplying everything inside of here by 5. 5 times -1 is -5. 5 times 4 is 20. 5 times 3 is 15. 5 times 0 is 0. As you can see, this is just a sneaky way for me to get you to do some mental math with integers.